One of the objectives is to record the frequency of rolling a die, whether it's an even number or an odd number. The second objective is to find the experimental probability of rolling an odd number of a die. Third, to find the theoretical probability of rolling an even and odd number of a die. Next, to calculate the percentage of the difference between experimental probability and the theoretical probability for even and odd number of rolling a die. Then, to identify the experiment whether it's a discrete random variable or a continuous random variable. Lastly, to determine mathematical expectation involving mean and variance. The significance of this project is to learn how probability can be applied in real life and how it is useful for people. This can determine the number of different ways of arranging and selecting objects without actually listing them. For this project, we are using the technique of rolling a die to discover the probability. Probability is used to predict the outcomes of rolling a die, and we are going to observe whether the outcomes are even number or an odd number. From this experiment, we can evaluate how much the outcomes of number 1, 2, 3, 4, 5, and 6 will be the outcome. In this project, we require 30 trials for the outcomes. Then we use the formula of probability in addition to complete this project. Furthermore, the project can improve our knowledge about this topic.
Firstly, this is the data that we gain from experiment. Question A, in order to find the experimental probability of rolling an even number, we are going to take number of times of rolling an even number, of which is 12 over the total of times the experiment is conducted, which is 30. So we have 12 over 30. We simplify, we get 2 over 5. For question B, the experimental probability of rolling an odd number, we are going to apply the same formula, which we will get 18 over 30. Simplify, we get 3 over 5. Next, to find the theoretical probability of rolling an even number, we simply write the number of desired outcomes over the total number of possible outcomes, which we get 3 over 6. Simplify, equal to 1 over 2. For question D, the theoretical probability of rolling an odd number, we apply the same formula, which we will get 3 over 6. Simplify, we get 1 over 2. For the next question, what is the difference between experimental probability of rolling an even number and theoretical probability of rolling an even number. This is the formula: experimental probability minus theoretical probability times 100%, which gives us 2/5 minus 1/2 equal negative 1/10 times 100% equal to negative 10%. Next, what is the difference between experimental probability of rolling an odd number and the theoretical probability of rolling an odd number? So we are going to apply the same formula, which is experimental probability minus theoretical probability times 100%, which gives us 3/5 minus 1/2 equal 1/10 times 100% equal 10%.
For question A, we are going to compute the probability of a consumer that has to wait for at most 2 minutes. The question is about continuous random variable, so we are going to use formula of integration of a to b fy dy. First, we have to integrate the integration of 0 to 2, 0.5 plus y over 6 dy. Then take out 1/6 from the integration, so become 1/6 integration of 0 to 2, 0.5 plus y dy. So we are going to integrate 0.5 plus y. So become 1/6 bracket 0.5 y plus y square over 2 close bracket 0 to 2. Next, replace 2 and 0 into y, so become 1/6 bracket 0.5 times 2 plus 2 square over 2 minus 0.5 times 0 plus 0 square over 2 and close bracket. So the last answer is 1/2.
So next we go to the question B. Calculate the expected waiting time of customers to receive their order. So based on the question, it wants us to find the EY or mean of the variable. So the formula for continuous random variable for EY is integrate positive infinity to negative infinity y multiply with function y dy. So we insert the function y, 1/6 multiply with 0.5 plus y and multiply it with y and integrate to 3 into 0. And after we integrate it, we get 0.5 y square over 2 plus y cubic over 3, and we insert 3 and 0, and we got the answer 1/6 multiply with 45/4, and we get the answer, which is 50/8 or 1.875.
For C, to find variance, use formula of expected y squared minus mu squared. To find expected y squared, integrate the integration of 0 to 3y squared fy dy. Integrate 0 to 3y squared times 0.5 plus y over 6 dy. You will get 1/6 integrate 0 to 3 0.5 y squared plus y cubed dy. Then, from the integration, you will get 1/6 bracket 0.5 y cubed over 3 plus y in the power of 4 over 4, then close bracket 0 to 3. 1 over 6 in bracket 0.5 times 3 cubed over 3 plus 3 the power of 4 over 4 minus 0.5 times 3 over 3 plus 0 the power of 4 over 4. Then close the bracket. You will get 0 over 6 in bracket 4.5 plus 20.25. And the last answer is 4.125. So we can find the variance equal to 4.125 minus 1.875 squared. And the answer will be 0.6094.
Based on the study, we can conclude that when during experimental probability, the chance of getting the even number and odd number when rolling a die is totally different. For this study, we had recorded the outcomes for 30 trials, and the probability of rolling an even number, which is 2, 4, and 6, is 2 over 5. And the probability of rolling an odd number, which is 1, 3, and 5, is 3 over 5. But theoretically, the probability of rolling an odd and even number is the same value, which is 1 over 2. Finally, we want to say thank you to Madam Fatiha for giving us the guideline, the instruction, and helping us to finish this project. Thank you, Madam.